Richard James Mathematics Resources will present to you Grade 4 Practice Paper 1A. And this is our first practice paper in Grade 4 Numeracy. As a matter of fact, the video presentation will have the solution of 12 examination papers, with the exception of the last video, which is the D videos. We have this presentation divided into 4 parts, and the first 3 parts will involve the solution of 12 examination problems. As usual, Jerry Lewis is here with me, and is my well-abled assistant, but he's always in a hurry when we are working with mathematics. He's in some gear today, pretending as if he's on his way to playing some football game, because he wants to be right out of here as soon as possible. But he will get his opportunity to go within a few seconds. We'll take a look at the first problem. And our first problem involves the addition of 1,321 and what number? Right, that's correct. 708. What do we do? Well, let's take a look at what we have in store for us on this slide. So, let us add the numbers by writing down the first number. So let us write the first number down, which is 1,321. Take note of the place value of each digit. It is not completely necessary for us to take note of the place values as long as we have the digits properly vertically aligned. But writing down the place values will give a bit of information and let us understand and keep it in our minds as to the actual place values of the digits in the numbers that we are adding. To the extreme right, we have our ones digit, then we have the tens digit, hundreds digit, and thousands digit. Next, write 798 by first placing the ones digit under the ones digit. So, the ones digit that we have right here is the 1, which is the one that we have right here. The ones digit of 798 is this 8 that we have right here. So, it will be vertically aligned with this 1. So, it will be placed below the ones digit. And where will we place this 9, Jerry? Right. It will be placed under the tens digit, because as a matter of fact, it is the tens digit in 798. Well, Jerry is not speaking so loudly. Maybe he's afraid that his answers are incorrect, but so far, all of his answers are correct, so he's at 100% in the questions that I'm asking him so far. Place the tens digit under the tens digit. Jerry said that we should place this 9 because this is the tens digit, so we place that tens digit right below the 2. And finally, place the hundreds digit under the hundreds digit. And what is the hundreds digit in this particular case? Right, it is 7, because it's the only one that we have left. And we have the ones, the tens, and the next place value will be the hundreds. And what do we do after that? Write your addition sign and draw your line. When you are adding numbers, when we are all adding numbers, it is very important for us to follow certain principles, certain formats. And in adding, we need to underline and also place the addition sign so that it is quite visible that others may look at the problem that we are solving and be able to tell that we are actually adding those numbers. We are about to add. So what digits do we add first? Right, so we will add the ones digit first. And we add in mathematics, beginning at what we call the rightmost digit, which is the digit to the extreme right. So that is the one that we will add first. So begin by adding the ones digits. So we'll add those ones digit first. 8 plus 1. Right, so 1 plus 8 is equal to 9. 1 plus 8 is equal to 9. What do we do with that 9? Because it is the ones digit that we are adding, the result will go in the ones column. And after adding those numbers in the ones column, what do we do? Right, we will go to the tens column. Right, so we begin and we go in order from right to left. Add the tens digits. What do we have there? 9 plus 2. And that will be equal to 11. Right. 9 plus 2, and that will be equal to 11. What do we do? Do we put both digits under the tens digit? Do we put the 11 right here? Right. So according to what Jerry Lewis explained, we should put 1 down. So place 1 in the ones column and carry 1 to the hundreds column. Why is that so? So 1 goes there and we carry 1 to the hundreds column. Why do we do that? We do that because when we add the 9 and the 2, the result is 11. Like what we have right here. Now, although this is a ones digit and this is a tens digit, because the digits are actually in the tens column, this one here will be a tens digit. And this one will be a hundreds digit. Because if you are in the tens column, the rightmost digit in the tens column is the tens digit. And then the one higher in place value will be the hundreds digit. So if we put the 11 right here, with a 1 here, and the other one will go here. So the other one will go into the hundreds column, the one of higher place value. So we have this one, which will be the tens digit, because we are in the tens column. This one will therefore be the hundreds digit. So that is why it is taken to the hundreds column. And let's see if we can give an explanation for that when we get to the hundreds column also. So add the hundreds column. What are the digits now that we add in the hundreds column, Jerry? Good. So we do not just add the 3 and the 7 only, but we also add the 1, because we got 11 here, and the right digit is actually the tens digit, so the left digit turns out to be the hundreds digit, and it is in the hundreds column. So it is also added with those digits that were already in the hundreds column. So let us add. So there we go. Go ahead, Jerry. Right. So 7 plus 3 plus 1. What is that equal to? That is equal to 11. So what do? We do the same thing or something similar to what we did just now. where we know that because this is an 11, the right digit being in the hundreds column will be the hundreds digit, and the digit higher in place value will go to the thousands column because it will be a thousands digit. So if you have two digits, whatever digit the right digit is, then the left digit will be the digit higher in place value. So if I'm adding in the tens column, the right digit will be the tenth digit, and the left digit will be the hundredth digit. Now that we are in the hundreds column, and we have 11 hundreds, we will keep this 1 in the hundreds column, and then the left digit will be higher in place value. So it will go to the thousands column. So place 1 in the hundreds column and carry 1 to the thousands column. There we go. And finally, what do? Add the digits in the thousands column. So add those digits, what do we get? 1 plus 1 equal to, any number to carry? No number to carry. Therefore, the 2 is just placed in the thousands column. So the answer is 2,119. And that is represented by which option? That is represented by option B. By option D. So I was just corrected by Jerry Lewis, who is very attentive and saw that I supplied the incorrect option for the answer. Now, what do we have here? What sign is this, Jerry? Right, so that is our division sign. That is our division sign. Therefore, what we have here is a division problem. This is a division problem. Let us set up our division format and use short division. So we will solve this problem by making use of short division. So we have 124 to be divided by 4. So we'll take that 124 that we have there, and that is how we show that we are dividing. And we are dividing by 4. And in a division problem, the number that we are dividing by is called the divisor. And the number that we are dividing into is called the dividend. Right. So, when we are dividing, we take our divisor and we begin at the extreme left of the dividend. So we will say, first of all, 4 into 1. Can 4 go into 1? Why can't 4 go into 1? Because for you to be able to divide 4 into 1 or 4 into any number, the number that you are dividing into has to be greater than 4. So if it is not greater than 4, you cannot divide 4 into that number. So 4 into 1, we can't. And when we study mathematics later on, we will get our better definition of what we mean when we say that we can't. Because what we mean is that we cannot do that a whole number of times. But surely, any division is possible. But because we cannot get a whole number for our answer, we will move on and say 4 into 12. So 4 will not divide into 1 a whole number of times. So we cannot put a whole number right here above the 1, because 4 will not go into 1 a whole number of times. But we will move on and say 4 into 12. So we begin at 1. 4 into 1 cannot go a whole number of times, so we say 4 into 12. And if 4 could not go into 12 a whole number of times, then we will move on to 124. But for sure, 4 can go into 12. Can 4 go into 12? 4 into 12, how many times? Okay, good. 4 into 12 goes 3 times. 4 into 12 goes 3 times. In subsequent videos that we're talking about, the videos to follow this one, we will have more detail as it pertains to division. But when we get there, we will make use of those details. So for now, get the gist of division, because we cannot possibly explain every detail in one single video. And that is why the grade 4 numeracy will be presented in 20 mathematics videos. And of course, we will give additional detail in some of the subsequent videos. So we then say 4 can divide into 4 one time and place the 1 above the 4. So after saying 4 into 12 is 3 times, then we say 4 into 4 will be 1 time. Any number divided into itself will be 1 time. And later on, although we'll make more use of it later on, I'm saying it now. I am saying it now. When you are dividing and you do not see the answer immediately, make use of your multiplication tables. By making use of your multiplication table, for example, your 4 times table. Let's go, Jerry. 4 1s 4, 4 2s 8, 4 3s 12. Right. So because 4 3s 12, then we know that 4 can go into 12 3 times. Because when we multiply 4 by 3, the result is 12. And you need to understand at this level that division is the opposite of multiplication. Right. The answer is option A. What is 105 multiplied by 6? When we multiply 105 by 6, what is the result? Let me see if Jerry can give an example or give an answer. 105 multiplied by 6, Jerry, what's that? 630. Right, bright boy. 630. And that is represented by what? Option D. That is represented by option D. So what Jerry did is just 6 5s 30, 6 1 6. And that's all there is to it. 630. But let us first write down 105. First write down 105. So that is what we have, 105. Next, write 6 under the ones digit. It is important for us to understand that when we are about to solve a mathematics problem, format plays a very important role. We cannot just take numbers and just multiply them like that. Because what can be the result if we just take the numbers, put them anywhere on the page, and then multiply? What could possibly go wrong, Jerry? We'll get an incorrect answer. That's a possibility. Because you know that when you are multiplying, you have to make use of the place values accurately. And if you do not make use of the place values accurately, then you will place the digits in the incorrect place. And that will affect the accuracy of your answer. So when we are multiplying, this number is called the multiplicand. And this one is called the multiplier. The multiplier must be vertically aligned with the multiplicand in such a way that the ones digit of the multiplier is below or vertically aligned with the ones digit of the multiplicand. Next, write the multiplication sign and draw the line below which the answer will be placed. So, we have the multiplication sign, we have the line right here, and the answer will be placed below the line. And this is your general format for multiplication, because you have to have your multiplication sign. This explains your intention. And your numbers must be properly vertically aligned. So what do? First, we multiply 5 by 6. So we take the multiplier and we multiply the ones digit first. So we say 6 5s, and that is equal to? Write down the 30, Jerry. Write what? Okay, I'm sure that you can hear that. So we will write the 0 down, and the 3 will be carried to the tens column. Because right here we have 3 and a 0. The 0 will be vertically aligned with the ones digit, and the 3 will be vertically aligned with the tens digit. So this 3 actually represents 3 tens. So write down 0 and the ones digit. Write down 0 under the ones digit and carry 3 to the tens column. What do we do next? Okay, so what we are required to do is 6 times 0. What do we get when we multiply 0 by 6? Any number multiplied by 0 or 0 multiplied by any number is 0. So 6 zeros will be 0, and what do? We add the 3 because we have the 3 tens here that was carried over from the ones column. So we have 3 tens to be added to the 0. So multiply 0 by 6. What do we get? 6 times 0 is equal to 0. But it does not stop there because 3 was carried over from the ones digit or the ones column. So add 0 to 3 and write the result under the tens digit. So when we multiply 6 by 0, we get 0, and then to that 0 we add 3, and that 3 will be placed in the tens column. Anything to carry? No, nothing to carry. We multiply 1 by 6, and what do we get? 6 ones? Okay, so 6 ones, 6, and we just write down the 6 in the hundreds column. So it goes right there. So the 6 must be placed under the hundreds digit. And that is why when we are solving problems, mathematical problems, problems in arithmetic, it is important for us to have our numbers vertically aligned, and we need to stick to a particular format that may be used in helping us to arrive at the answer accurately. So the correct answer is option D. Correct. So we have another division problem. According to the format that the problem has, we should divide. So division is required. If we look again there, all the way back, we will see the division problem that we had. And in that division problem, we were not given the format. We were just given the statement right here, and we were required to tell that the problem is division. On this occasion, what is happening is that we are already given the division format, and we are about to divide. So in this number, which number are we dividing by, Jerry? We are dividing by 2. And 2 is the divisor. And the number that we are dividing into, what is that number, Jerry? 1,840. Right. So 1,840 is the dividend. And the answer when we divide is called the quotient. So according to the format of the problem, division is required. So let us divide. So what do we say? You cannot say that you did not see something like this before, Jerry, because we just saw it 2 problems ago. So what do we say now? 2 into 1. Right, 2 into 1, we can't. We cannot do that a whole number of times. Therefore, what do? Do we put a 0 here? But if we put a 0 there, it is not incorrect. Right. So we could put a 0 there, but leading zeros do not affect the value of the number. And because it is what we call in mathematics insignificant, we do not have to include it. So we say 2 into 1, as we have there. We will first attempt to divide 2 into 1. We can't do that a whole number of times. So we say 2 into 18 equals, how do we know that 2 into 18 equals 9? Well, say the 2 times table. 2 1s 2, 2 2s 4, 2 3s 6, 2 4s 8, 2 5s 10, 2 6s 12, 2 7s 14, 2 8s 16, 2 9s 18. Right, and in the old days, when we reach 9, we used to say 2 9s are 18. Yeah, right. So we usually say that in a different way when we are at 9. So 2 9s 18. So because 2 9s 18, then 2 into 18 will be 9 times. And that is how useful your multiplication table is. And Jerry is very sharp on his multiplication table. So I hope that next time when we have to say the multiplication table, he will say it a little bit more loudly than he did on the previous occasion, so that you can hear his voice in the background. I can hear it, but I'm not so sure that you can. Now, after 2 9s, 18, or 2 into 18 goes 9 times, we say what next? We then say 2 can divide into 4. How many times? 2 times. So 2 into 4, 2 times. And then what next? 2 into 0. Right. So although on this occasion, 2 into 0, we cannot do that a whole number of times, can we? No. But do we leave the 0 out? Right. So we cannot leave the 0 off like we have neglected it right here, because the 0 here is occupying significant place. So it has a significant place right there. So we say 2 into 0 will be 0. So divide 0 by any number and the result is 0. 0 is placed above the 0. What is the correct answer? The correct answer is option B. Now, as we said before, we cannot neglect the fact that we need to include a 0 right here, because this 0 is in what place value position? The ones place value, right? It is in the ones place value column. That is where the 0 is. And if we do not place it here, then the number will just be 92. And we are sure that our answer could not be 92 if we are dividing all of 1840 by 2. There's no way the answer could be 92. So we did well to include the place holding 0 right there above this 0, so that we have 920, which is the correct answer. Now, Jerry, this is the one that you fear the most. Subtraction. How do we know that this is a subtraction problem? There's nothing in the statement of the problem saying that we should subtract. As a matter of fact, we do not have a statement of the problem here. All we have are these options. How do we know, Jerry, that we are required to subtract? Because we have a subtraction sign right here. So you heard that we have that subtraction sign. So what do we do? The subtraction sign tells us what to do. We will begin, as always, at the digits with the smallest place value, which is at the extreme right. So we will begin at the extreme right. What do we find at the extreme right? We will find the digits with the smallest place value. So we will add and subtract. We even multiply with the smallest place values going first. But when we were dividing, we use the largest place values first. So let's go. We cannot take 9 from 2. So the first thing that we need to say is what? 2 subtract 9. Can you take 9 things from 2 things? We cannot take 9 things from 2 things. So what do? We go over to the 10th line. Right. So we go over to the 10th line. So this is the 10th, T-E-N-T-H-S, the 10th line. Because this is the 100th column. And when we are doing the subtraction on subsequent slides, we will put all of the place values. But we are trying to give you the details a little at a time. Right. So we say 9 from 2, or 2 take away 9. We can't. Right. So we say 9 take away 2. And we can't. So according to what Jerry Lewis suggested, we should go over to the 10th column and take 1 from there. And the word that we use in mathematics is rename. So we will go over to the 10th column and rename the 6. So we will remove 1 from this 6 and it becomes 5. And then when we take it here, what do we know? When we take the 1 here, what is going to be the result? Then the 1 taken from the 6 will be 10 times its original value when it is taken to the column of less place value. So the 1 that we remove from here, when we take it to this column here, right, which is the 100th column, right, we have right here, as we always do, irrespective of where we are at in our place value, the place value to the left is always 10 times the place value. Let me say that again. The place value to the left is always 10 times the present place value. Therefore, when we are at the 100th place value, if we reduce a 10th digit by 1, because the tenths are 10 times the hundredths, then when we take the digit here, which is a single one, we will have what? 10 hundredths. So 1/10 is actually 10 hundredths. And if we come right here, the same thing is true. We are right here in the tens column. And if we take one from this column, which is the hundredths column, and we are using it in the tens column, 100 is 10 tens. So because 100 is 10 tens, when we take 1 from the hundreds column and bring it here, it is going to be 10 tens. So the same thing is true right here. When we take 1 from the tenths column and we bring it here, it is what? 10 hundredths. So, because it is 10, 10 plus 2, what does that give? It is 12. So we are actually now subtracting 9 from 12. And 9 from 12 gives what? Gives 9 from 12 will give 3. Next, we move to the tenths column. And as a matter of fact, in subsequent slides, we will see the place values given more often. But we are paying special attention on this occasion to the subtraction process. So, since this 6 was renamed to 5, 4 is now subtracted from 5, and the result is 1. What do we do next? Do we say 0 from 1? What do we say then? Right. So we are adding numbers that contain decimal places. So right now we are at the decimal places. So place the point under the points. Or we may say that we are vertically aligning the points, because this answer also needs to have its decimal point. So the decimal point will go right there. Then what do we say? We say 1 minus 0, or we say 0 from 1. If you have something and we do not take away anything, it's going to be the same thing that remains. So we do that. 0 from 1, or 1 minus 0 is 1. And what do we do next? We say 8 minus 3, or 8 take away 3, or 8 subtract 3, and the result is 5. So 5 goes right there. And then finally, what do we say? We will say, take away nothing. There's nothing to be subtracted from the 3, so 3 goes there. Say, there is nothing to be subtracted from that 3, so 3 goes there. And that is represented by option B. The correct answer is therefore option B. Which fraction is the same as 2/3? That is your question. What fraction is the same as 2/3? Which one of these is the same as 2/3? In finding out the one that is the same as 2/3, we can go through a lot of different processes. As a matter of fact, we might use just common sense without using anything mathematical, and maybe eliminate those answers that are impossible to be correct. But let's see what we do in order to find our answer. The fraction that we have there is in its lowest terms. What do we mean, Jerry, when we say that the fraction is in its lowest terms? Alright, we cannot cancel down the fraction. It means that we cannot divide or use any number that can divide into 2 and use that same number to divide into 3 so that we'll get smaller numbers. So there's no way to write this fraction by using smaller numbers. The numbers that we are using right there are the smallest numbers that we can use to represent this fraction. So we will attempt to reduce the other fractions to their lowest term and see which one is equal to 2/3. Right, so that is one method. Because we want to see which fraction is the same as 2/3, we will reduce or attempt to reduce these fractions to see which one will actually reduce to give 2/3. And the reduction process is by what we call cancelling. But let us see what we'll make of this problem. So the first one that we have right here is 3/4 or 3/4. The numerator and the denominator do not have any common factor. There is no single number that can divide into both of them without leaving a remainder. Correct? Correct. Can we find a number that can divide into 3 and that same number can divide into 4 without leaving a remainder? Unless that number is 1. And if you divide 1 into 3, you will still get 3. And if you divide 1 into 4, you will still get 4. So there is no number that we can use to reduce this fraction any further. Now, in mathematics, students who do things incorrectly may want to reduce the fraction by subtracting 1 from both numerator and denominator. So let us look at this. If we do that, say subtract 1, 3 minus 1 is equal to 2. And if we subtract 1 from 4, 4 minus 1 is equal to 3. Right. So what do we get for our answer now? The answer that we get by reducing the fraction in the manner that we just did is 2/3. But is it correct? No, it cannot be correct. Why? We have shown that the fraction is equal to the 2/3 that we have right here. So 2/3 is the number that we want, is the fraction that we want. We want to know what number is the same as 2/3. When we reduce this fraction, what did we get? 2/3. Why is it that 3/4 is not the correct answer? It is not the correct answer because the correct method was not used in reducing the fraction. Okay. So what do we say? The fraction that we have is in its lowest terms. And we said that before. How do we know that it is in its lowest terms? Because its numerator and the denominator do not have any common factor. There is no single number that can divide into both of them without leaving a remainder. Well, with the exception of 1. And if we use 1, then the fraction will not be reduced. Because if we use a common factor of 1, what will happen? When 1 divides into a number, the number will remain the same. So 1 cannot be used as a common factor to reduce fractions. So let us take a look at the fraction in option B. What about the fraction that we have in option B? What do we say about it? The fraction is in its lowest terms and it has the same numbers as 2/3. So we have 2/3. We have a 2 and a 3. But we do not have 2/3. It has the same numbers as 2/3, but the denominators and the numerators are not arranged in the same way. It is not equal to 2/3. So although we have a 3 and a 3, we have a 2 and a 2. The fractions are not equal, they are not the same, because the 2 is in the numerator in this case, and the 2 is in the denominator in this case. So those two fractions are not equal. Let us take a look at the fraction in option C. What about option C? The numerator and denominator have a common factor of 3. 3 may divide into 9 and 6 without leaving a remainder. We may say that both 9 and 6 are divisible by 3. When 3 can go into a number without leaving a remainder, we say that that number is divisible by 3. So 9 is divisible by 3 and 6 is divisible by 3. So what do? 3 into 9, or 9 divided by 3, is equal to? Right. And when you are dividing, you may do well to consider your multiplication tables, because 3 times 3, or 3 3s, 9. Right. 3 1s 3, 3 2s 6, 3 3s 9. So because 3 3s 9, when we say 9 divided by 3, the result is 3. What about 3 into 6? 2 times. 3 2s 6. So 3 into 6 will be 2 times. And that fraction will be 3 over 2. Is that correct then? It's not correct, right? So it's not correct. The resulting fraction is equal to the fraction in option B. Do not forget that, see, when we reduce the fraction, we get the same result as in option B. And we said that the answer in option B is incorrect. Therefore, this one has to be incorrect also. The fraction in option D may be reduced by a common factor of 4. Why do we know that this one can be reduced by a common factor of 4? Why? Because 4 can go into 8 without leaving a remainder, and 4 can go into 12 without leaving a remainder. And I thought that Jerry Lewis would say that when I say, how do you know? Because we know that because our multiplication tables, right? Our multiplication tables tell us that 2 4s, 8, and 3 4s, 12. Or we may say 4 2s, 8, and 4 3s, 12. So, because of our multiplication table, we are aware that 4 will divide into 8 and into 12 without leaving a remainder. So if you do not know your multiplication table, then you will be hobbling around on one foot in this mathematics camp. But Jerry knows his multiplication tables, and he's having no difficulty, absolutely no difficulty whatsoever. So we reduce that by a common factor of 4. 8 divided by 4, and the result is 2. 12 divided by 4, and the result is 3. So what is our answer? Right. So we have 2 over 3, or 2/3, when we reduce the answer in option D. And it turns out to be the exact one that we have right here. Therefore, option D is correct. So the resulting fraction is the same as the one in the question. So option D is correct. Let us take another look at our problem. Which fraction is the same as 2/3? some of the incorrect answers could have been easily identified. When we have a multiple choice examination to do, it is not only about finding the correct answer. Sometimes it is about throwing away the incorrect answers. Because if we throw all of the incorrect answers away, the only one that will remain will be the correct answer. Notice that the fraction in the question has the numerator smaller than the denominator. It is an example of a proper fraction. So when we have a proper fraction, the numerator is smaller, and that is what we have in the statement of the problem. The statement of the problem has a proper fraction with the numerator smaller than the denominator. There it is. That is your numerator. Is there anything else? There's your denominator. So your numerator is 2 and your denominator is 3. And the numerator is smaller than the denominator, so your fraction is called a proper fraction. An improper fraction has its numerator bigger than its denominator, or greater or larger than the denominator. It cannot be the correct answer. Therefore, if your problem has a proper fraction, the options contain improper fractions, then the improper fractions cannot be correct. And the improper fractions are those in option B and option C. So those are incorrect because they are improper fractions. They cannot possibly be equal to a proper fraction. So we are only here now having 2 options remaining. The answer could have been found by multiplying the numerator and denominator of the original fraction by a common factor. So instead of reducing this one by a factor of 4, we could multiply this one by a factor of 4. And if we get 8 over 12, then we know that this option is actually equal to 8 over 12. So let us go ahead and do that. What do we say? 2 fours, 8. 3 fours. So what is our answer? Right. The correct answer is actually 8 over 12, which is in our option, which is option D. And that one is actually equal to our number 2 over 3. So whereas we reduce this fraction to show that it is equal to this one, we could have multiplied this fraction by a common factor to show that it is equal to this one, which will cause this one to be our correct answer. It is better to reduce the fractions in the option because the original fraction is in its lowest terms. Alright, so if we reduce the fractions to their lowest terms, it will be quite easily seen which one will be our correct answer because this one is in its lowest terms. So let me repeat that. If we reduce the fractions that we have in the options to their lowest terms, it will be easy to see the correct answer because the one in the statement of the problem is in its lowest term. Problem number 7. And we are required, what are we required to do with all of these numbers, Jerry? We are required to add those numbers. And what gives us the idea that we should add? We have these signs. We have the addition signs right there. Good. So this tells us that we should add. We are required to add. So begin by adding the digits to the extreme right. They have the smallest place values. Now, when we are adding we have done some addition before. But it is important that we know that we need to add beginning at the extreme right. At the extreme right. And at the extreme right, we find the digits with the smallest place value. So we will add those. 8 plus 2 plus 5, what's that equal to?
15.
Alright, so that is answered very quickly. So we have the answer coming very quickly by Jerry. So Jerry is sharp on his addition. And you can be very sharp on your addition also, because what Jerry did just now is he added the 8 with the 2, and that's 10. So the 5 added to 10 will give 15. Now, it is good and it is easy for you if you know the numbers that will add to give 10, like 8 plus 2, 9 plus 1, 6 plus 4, 7 plus 3, 5 plus 5. So adding in groups of 10 makes addition very simple, and that is the method that Jerry used just now. So when we add those, Jerry got, as a matter of fact, 15. So what do we do with that 15? Do we put 15 right here?
No.
No. What do we do instead?
We put the 5 down and carry the 1.
Okay, good. So put the 5 down and carry 1. So let us write down that 5 and we carry the 1 to the 10th column. Now, do not worry, because we did not choose to put the place values right there. But I am sure that for the subsequent videos, the videos to come, we will have more details than we have right here. As a matter of fact, we do not imagine that we can put all of the details in a single video presentation. So if you continue to pay attention to Richard James Mathematics Resources with his grade 4 numeracy presentations, I am sure that you will see all of the place values and all of whatever it takes to make the solution of the problem very plain and simple. But for now, we are just focusing on adding the digits. Do not forget that your 5 will be right here in the hundredths column, and the 1 will be carried to the 10th column. Also, it is important for us to bear in mind that when we are at a particular place value, the place value to the left is usually 10 times the present place value. Move on to the next column. What do? We will add those. What do we get when we add them?
3 plus 1 plus 3 plus 1 plus 4 plus the 1 that we have give you 9.
Okay, so this is 9. And on this occasion, Jerry is careful to include the 1 that we carried from the previous or the hundredths column. Do we have anything to carry? Right, so we have right there no carry. So 9 goes there. Do we move very quickly and start to add these digits, Jerry?
No, we have to put down the decimal point.
Okay, so we need to include the decimal point in our answer because we are adding numbers that contain decimal fractions. The decimal point is very important. So place the dot, which is the point, vertically below the others. When we place them vertically below each other, we say that they are vertically aligned. Add the digits in the next column, and the next column will be our ones column. So we'll add those, and what do we get?
11.
Right. So we have 5 plus 2 plus 4, and that is equal to 11. And you might get your 11 in any way that you choose, because what I did is I added the 2 plus the 4, I got 6. 5 plus 6 equals 11. And one might want to say 5 plus 2, 7, and then 7 plus 4, 11. So you want to do it that way, or you might just do it in any order that you please. Any way that makes addition easier for you. So we have 5 plus 2 plus 4, and that is equal to 11. What do we do?
Put down the 1 and carry the 1.
Right. We put down 1 and carry 1. And because both digits are 1s, some students may be at a loss as to say, which one do we carry? We carry the digit of greater significance, or the one that has the greater place value. So this one is the one that we place in its rightful position right here, and the other one is the digit of greater place value. It will go to the column of greater place value, and that we will clarify when we are adding numbers and the two digits are not the same. So write down 1 and carry 1 to the next column. There we go. Again. What do we do next? We go to the next column and we add the digits there. What are the digits that we add there?
8 plus 1 plus 1.
Alright, so we have 8 plus 1 plus 1, and that will give what?
10.
Okay, so 8 plus 1 plus 1 is equal to 10. So, do we put down 1 and carry 0?
No, we put down the 0 and carry the 1.
Okay, so we will put the 0 down and carry the 1. As I mentioned before, we are adding right here. So this digit will be the digit that goes in that same column. And this will be the digit of greater place value. It is going to be carried to the greater place value. So we'll take the digit which is the 1, the digit of greater place value, and it will go to the greater place value. And finally, what do we do? Finally, add 3 and 1 that we have right there, which is, that will give us 4, and we just place the 4 right there. We may now declare our answer. I'm just going to hide that and ask Jerry, is there anything left that we need to...
Because we're dealing with dollars, we need to put down the dollar sign to indicate that we're dealing with money.
Okay, so what we have right there is that we need to include the dollar sign in our answer. Also, as a matter of fact, notice that the dollar sign is present in all of the options. So the answer cannot be correct without the dollar sign. And you will learn at this early stage that when we have units or we have symbols that we need to include, that the answer is not 100% accurate without those units or without these symbols that we have right here. So we need to include the dollar sign in order that our answer will be complete. There it is. And what is our correct answer on this occasion?
Option A.
Right, so the correct answer is option A. Which gives a multiple of 12. Which one of these numbers we have right here is a multiple of 12? When you hear the word multiple, which other word comes to mind, Jerry? Multiply. That's correct. So a multiple is obtained by multiplication. Right. So the one that is a multiple is the answer that we can get by multiplying 12 by a whole number. Right? Multiple has to do with multiplication. So a multiple of 12 is a number that we can get if we multiply 12 by a natural, a whole number, or a counting number. So if we multiply 12 by a natural number, the result will be a multiple of 12. Right, so we have 12 multiplied by 2, and the result is equal to 24. Which option is that, Jerry?
That is option D.
Right, so that is represented by option D. So option D is the correct answer. What about these? Is there any discussion that we can have based on these numbers?
Yes.
Good. The other numbers are not multiples. We will have to divide 12 by another whole number in order to get them. So 6, 4, 3. Those are not multiples of 12 because there is no number that we multiply. There is no whole number, no natural number, no counting number that we can multiply by 12 and the result is either 6, 4, or 3. So there is no number that we can multiply 12 by in order to give these. So these are not multiples of 12. So we have 12 divided by 2 and the result is 6. So what do we say about this? Remember, we say that when we multiply 12 by 2, the result is 24. So 24 is a what of 12?
A multiple.
Right, 24 is a multiple of 12. When we divide 12 by 2, the result is 6. So 6 is a what of 12? Alright. So 6 is a... What do you say, Jerry?
Factor.
Right. So 6 is a factor of 12. So we have 12 divided by 3 and the result is?
4.
And we get also 12 divided by 4 and the result is?
3.
Right. So these numbers that we have here are?
Factors.
Right. They are actually factors of 12. And in these videos presentation, we will no doubt get the opportunity to explain more about multiples and factors. The word multiple is similar to the word multiply. The answer is the result of multiplying 12 by another number. So we multiply 12 by another number and the result will be a multiple of 12. So at this stage we may just say another number, but in the future when you are working with more sophisticated devices, you say a counting number or a natural number, and we will see natural numbers in our video presentation. We are required for number 9 to add
An whole number.
right, which is, so we have 3 and 2/7 to
3 and 7.
so 3/7. That's right. So we are adding 3 and 2/7 to 3/7. How do we do that?
First we have to find the denominator.
Right. We have to find the common denominator. But what do we know? The denominators are the same already. So we may go straight ahead and
Multiply. Add.
right. So we may go straight ahead and add the fractions. So what do we say? We say 3 and 2/7 plus 3/7. And we can do it any way we please. We may put the whole number down or we may add the fractions first. I prefer to add the fractions first. So one number is a mixed number and the other is a fraction. Just a single fraction. Begin by adding the fractions. So we will add the fractions first. So when we add these, what will be the result? Will it be 5 over 14?
No.
Okay, it will not be 5 over 14. And also we will explain those as we go along. because we cannot possibly explain everything on a single slide. So while adding the fractions, we do not add the denominators. The denominators are the same. So the answer will have the same denominator as these two. The fractions have the same denominator. So we will add the numerators and place the result over the common denominator. When we are adding fractions, the fractions have the same denominator. So we will have the same denominator in the answer, and we will add the numerators. That is how we do it. So add the numerators, we get 5 over 7. So the common denominator, these two are not added. And what do we do next? Well, I'm sure that Jerry will be able to tell us what we will do next. What's that?
Place the whole number beside the fraction.
Right, so the whole number will be also included. So the whole number is not to be left out. It will take its place beside the fraction. Right there, let's do it again. Okay, so the whole number is also included. So what is our answer? 3 and 5/7. And that is represented by option C.
No,
It is
option A.
alright, so Jerry is correcting me. It is represented by option A. Now we have one of my favorite problems. 2 minus 3/5. How do we do that? 2 minus 3/5.
2 is an whole number.
Okay, so 2 is a whole number.
And we're going to minus it from 3/5.
Okay.
So you put 2 over 1, at which you will come to a concluded denominator, because there are 2 different numbers.
Okay. All right. So Jerry is saying that we should write, which is a method, but it's not a method that we will use right here. The method that Jerry suggested is that we write this 2 as a fraction. And it is good that Jerry is pointing it out to us at this early stage that this whole number may be written also as a fraction with a denominator of 1. And all students need to know that if you have a whole number, it is equal to a fraction with what? The denominator of 1. Okay? Now, what we will do here is use another method in solving this problem. The method that we will use is we will take this whole. How many wholes do we have?
2.
Right. So, to subtract a fraction from a whole number, take one whole from the number and write it as a fraction. So that is what we are going to do first. So we have 2 wholes. So we take one whole and write it as a fraction. So if we take one whole from 2 whole, how many will be left?
1.
Right, so one of the wholes will be written as a fraction and the other will be unaffected. It will just be right there. So let us do that. So we have 2, 1 is a whole, and 5 over 5 is a whole also. So the 2 wholes that we have, one is left right here and the other one is written as 5 over 5 or 5/5. I also hope that we understand at this level that if we have a fraction, in which the numerator and the denominator are equal, then that fraction is equal to 1 whole. So this is 1 whole. This is another. When we put them together, we get what? 2 wholes. Right. So we intend now to do our subtraction. And these fractions have the same denominator, so we may subtract them immediately. How do we subtract numbers with the same denominator? The answer will have the same denominator as these two, because these are the same denominator. The answer will have the same denominator. So 1 whole is 5 over 5, or 5/5. Any number divided by itself is equal to a whole. 5 is used because, why do we use 5? Because we want to subtract the fractions easily, so we write this one with the same denominator that we have right here. So the two of them have the same denominator, but to make this into a whole, the numerator has to be the same. So that is why we write it as 5/5. 5 is used because it is the denominator of the fraction that we had before. So the fraction that we had, just this fraction alone, the denominator is 5. So when we are writing another fraction here, we will use the same denominator, which is 5. The fractions have the same denominator. Subtract the numerators and place the result over the common denominator. So the denominators here are already common. So the answer will have the same denominator as the common denominator. And the numerator will be found by saying 5 minus 3, which is equal to 2. Right, is equal to 2. We'll have 2/5. What do we do with this one?
We have to carry it over to the 2/5.
Right, so we will cause this one to accompany the 2/5. And in the old days, in mathematics, our teacher, if we don't put the 1 here, what our teacher will tell us that we did with it?
Eat it.
Right, the third teacher will tell us that we would have eaten it. So the teacher say, you ate the one that should be there, so your answer is not correct. So the whole number is not to be left out. It will take its place beside the fraction. Right, so right there. So the correct answer is 1 2/5, and that is represented by which option?
Option B.
Right, it is represented by option B. Which has the greatest value? Which has the greatest value? How do we know which number has the greatest value? The number that has the greatest value will have the largest digit in the largest place value. So right here, Jerry, look and tell me which digit has the largest place value. In these, which one has the largest place value? So the one to the extreme left will have the largest place value. So this is the largest place value, and therefore contributes more to the value of the number than the other digits. The largest place value contributing more to the value of the number than the other digits. Therefore, the largest number will be the one that has the largest digit in the largest place value column. So, this is the largest place value column. Which number has the largest digit in that column, Jerry?
2.
Look at this. Which one has the largest digit in this column?
5.
Right, 5. And notice that what? 5 is present here, here, and here. Notice that?
Yes.
Right. So, because 5 is the largest digit in the largest place value column, and it is present in all those 3 numbers, it means that we will have to check other digits. However, because of that, we are sure that this one cannot be the largest number because it has the smallest digits in the largest place value column. So we can eliminate that one. The one with the greatest value will have the largest digit in the position of largest place value. Largest place value. Look for the largest digit, 5. The largest place value is located at the extreme left. Right. There we have what? The largest place value digits. We have 3 numbers with the largest digit in the largest place value. The other one cannot be the correct answer. So this one is automatically out. Why? Because the leftmost or the largest place value digit is less than the largest place value digits of the other numbers. So what do we do? All of these have the largest digit in the largest place value column. So what do we do? For the 3 numbers, we will compare the next placed value. So compare the next place value. We cannot use these to decide because all of these are equal. So we come to the next place value and we look at the largest digit. What is the largest digit that we have in the remaining numbers?
3.
3. And it is present in 2 of them. So we are sure that this one cannot be the largest because in the red it's a 2. So the one we are comparing at this present moment, the second most significant place value. This one is the most significant and this one is next in line in significance. And of course the smallest digit here is the 2, so that one has to be automatically out. The largest digit is 3. The one with the smallest number is 2. And that one is not correct. It cannot be correct, so it is eliminated immediately. So now, what do? Do we draw a conclusion based on this?
Yes. No.
Alright. So we cannot draw a conclusion based on this because the digits are the same. So what do?
Go to the next column.
Right, so we go to the next column, which is next in right, or next in significance. Right, and next in the order of the place value or the sizes of the place values. So we go to the next column. Which one has the largest digit that we have there?
The one with the 2.
The one with the 2. So the one with the 2 will automatically be the one with the largest value. So which has the largest value?
The one with the 2.
The one with the 2. Because when we compare the 5s, this one has the smallest. So we had to go to the 3s. Then we come right here and we will notice that the 2 is the one with the largest digit in that place value column. So we know that the other one is out, and which answer is correct?
Option A.
Right, so the correct answer is option A. In the following number sentence, what is 20 called? What is the 5 called? the multiplicand. And the 4 is the multiplier. And this one is the product, which is the result of multiplication. So we have the multiplicand, the multiplier, and the product. So in the following number sentence, what is 20 called? Notice that we are multiplying and the answer is 20. So multiplying, the result is 20. When we multiply, the result is called?
Product.
Right, it is called a product. Option A is correct. And we are finished. And the entire presentation is done. No, we do not operate like that. The two numbers, 4 and 5, they multiply to give 20. They are factors of 20. So 5 times 4 is equal to 20. So 5 and 4 are factors of 20. So 20 is a multiple of 4 and 20 is a multiple of 5. Right. So these two are factors of 20, but 20 is a multiple of these two. Sum is the result of addition and has nothing to do with the number sentence that we have right there. 5 multiplied by 4 is equal to 20. Sum has to do with addition, so that cannot be right. And the result here is the product. So we are sure that's not the factor. These are the factors. And what about this one, the remainder? A remainder is the amount that remains when one number does not divide into another evenly, or when one number is not divisible by the other number. We say that the number that remains is the remainder. So let us take a look at that. What are we about to do when we see this, Jerry?
Divide.
We are about to divide. So we say 3 into 7, and the result is?
2 times remainder 1.
Okay. All right, Jerry is very sharp and brilliant on that one. So we know that 3 will go into 7 2 times, because if we say our 3 times table, 3 ones, 3, 3 twos,
6.
right, 3 2 6. So if we say 3 threes,
9.
right, if we say 3 threes 9, the 9 will be greater than the 7, and we know that 3 will not be able to go into 7 3 times. So we are sure that it is actually 2 times. So 3 can go into 7 2 times. There we have it. However, 3 times 2 is what?
6.
Because 3 times 2 is not 7. That means there will be a remainder. So 3 2 6. And what do we do to get the remainder?
Minus.
We subtract the 6 from 7, and the remainder is?
1.
Very nice, Jerry. You are very happy that we are going to be at the end of the presentation in a short while. So I'm hearing Jerry loud and clear. When 7 is divided by 3, the result is 2, and the remainder is 1. There is a remainder of 1.